Good afternoon, everyone. We are looking at 9-3, rotations on the coordinate plane. A rotation turns a figure around a fixed point called the center of rotation. For our examples, the center of rotation is always going to be at the origin. And we'll rotate in increments of 90 degrees. You need to pay attention to the direction of the rotation. Is it going clockwise or is it going counterclockwise? Okay, so if we're looking at the way that this arrow is showing, where it says consider each quadrant as another 90 degrees, let's go ahead and say that this is our starting point, and how does that break it up? Well, if I do a complete circle, that's 360 degrees. A fourth of that, or a quarter of that, is 90 degrees. Then another 90 degrees would make it 180. And then finally, another 180 degrees would make it 270. Okay, so let's take a look at our figures that we have here. We have our pre-image A and we have our image A prime. So it looks like our figure is rotating this direction. That's clockwise. How many degrees would that be? Well, that's just one turn. So that's going to be 90 degrees clockwise. Now, what would happen if I started at our pre-image and went this direction instead? Well, that's 90 degrees here, plus another 90 would be 180, plus another 90 would be 270. So if I were to go counterclockwise, that would be 270 degrees. Okay, so a 90 degree clockwise turn is the same as 270 degrees. Let's look at B. Okay, B clockwise, again clockwise goes this way. So it's going to be doing 3/4 turns. So 90 times 3 is 270 degrees. If I went counterclockwise instead, that would just be 1/4 turn, which is 90 degrees. Getting the hang of it? If I go look at C and I go clockwise, that is 2/4 turns, so that's 180 degrees. If I go the opposite direction counterclockwise, guess what? That is also 180 degrees. So it doesn't matter if we go clockwise or counterclockwise 180 degrees. We're going to land on the same spot. All right, why don't you try D to D prime to go clockwise and then go counterclockwise. Okay, if you went clockwise, you did 3/4 turns. That would be 270 degrees. So that means counterclockwise is 90 degrees. Okay, E and E prime. Here's clockwise. Here's, whoops, I did it backwards, didn't I? I'm sorry. Okay, started at the wrong starting point. E is our starting point. Here's clockwise. Here's counterclockwise. But does it matter? No, they're both 2/4 turns, which is 180 degrees. It might help if you use one of the graphing boards in your classroom and label the quadrants, and you can see how they're broken up into fourths, and each turn is 90 degrees. Okay, and F, our last one that we're doing here, if we are going clockwise, that's a 90 degree turn. Counterclockwise, it's 270 degree. Whoops, 270 degree counterclockwise. Okay, so far so good? I hope so. All right, let's take a look at number 7. And what we are going to do here is we're going to rotate the figure to the right 90 degrees, then 180 degrees, and then 270 degrees clockwise. Okay, after each rotation, we're going to record the coordinates of the image, and then we're going to look at some patterns. So if I'm going to move the figure shown at the right 90 degrees, where is it going to end up? Okay, so it doesn't tell us, yes, it says to go clockwise. So if I go clockwise, this will be our first one here, and A is going to be here and here and here. Now, I'm going to be straight up honest with you. These are hard for me without using a marker board or something called patty paper. So I would suggest, if this is not helpful, to either grab some graph paper and create your own triangle. Sorry, I can't do two things at once. Or grab some patty paper like we used in our class yesterday and create your figure and do the rotations with it. So this is A prime, this is C prime, and B prime. Okay, we're going to rotate it 180 degrees from the original, and when I do that, I'm going to have 2, 1 over here. Oh, and you know what? Let's go back and go ahead and record our points for our 90 degrees clockwise turn. So this is going to be 1, -2. B prime is going to be 1, -6. And the last one is going to be 7, -4. So do you see what's happened with the coordinates? It looks like when we do a 90 degrees clockwise turn that the coordinates flip-flop. Instead of it being 2, 1, it's 1, -2. So watch what I'm going to do. I'm going to write my coordinates with a flip-flop. So what was X is now in the Y position. Let's try that again. What was Y is now in the X position. Okay, and X, or what is Y now, is the opposite of X. So what I did is I took A, basically I flip-flopped them. The 1 is now in the X position, the 2 is in the Y position, but it has to be its opposite. Okay, so that's just a little helpful thing that if you like to memorize things, you can. In your own words, what's happened here, or in my words, is the X and Y values switched, and the X became opposite. Okay, let's try that with a 180 degree turn. And if I do that with a 180 degree turn, here's our A double prime. B is over here. And C -4 is going to be down at -7. Okay, again, I have to do these with patty paper or a marker board. I think a marker board is going to probably be the best thing for you. So if you're doing these at school, ask Miss Bird or ask Miss Henry for a marker board. If you're doing it at home, try to grab some graph paper. Makes it a lot easier that way. All right, so let's look at the coordinates when we did 180 degrees counterclockwise or clockwise turn. The A prime became -2, -1. B became -6, -1. And C became -4, -7. So what you can see that happened with that, the X and the Y stayed in the same position, but they both became opposites. Okay, so the X and Y became opposites. Let's do one last one. Opposite signs, I should say. Okay, let's take a look at the 270 degrees clockwise turn or 90 degrees counterclockwise turn. So it might be easier for you just to do one turn that direction, and you might be able to see it a little better. But when you do, you're going to have 2, 1 right here. Or I'm sorry, that's actually -1, 2, isn't it? Okay, B is going to be at 6, 1. And C will be at -7, 4. I always am pretty envious of the people that can look at a figure and do rotations in their head. I'm pretty good with the translations and the reflections, but not so much with the rotations in their head. I have to, like I said, use marker board or patty paper. Okay, so let's go ahead and put those coordinates down. That's going to be a -1, 6, and this is going to be a -7, 4. The algebraic representation for this, you can see that the x and y switch position again. And that this time it was the y value that changed to its opposite. So the x and y value switched. And the y's became opposite. Again, I'm showing you this simply because if you like to memorize rules, it might make it easier for you, but you are not going to be tested on memorizing those rules. So much so that I'm not going to have you guys do these right here. Okay, so let's talk really quickly about do rotations preserve or change the orientation of the figure? So remember what we talked about preserving or changing orientation of the figure. Is the figure, remember when we did a translation, if we had a triangle that looked like this and we moved it up here, it still looked like that, okay? If we did a reflection and we had a triangle that looked like that, when we reflected it, its orientation changed, it flipped around. So when we do a rotation, usually what happens is we would have a figure that does something like this, and when we turn it, it now is changed. And it is hard for me to draw this, but it would kind of look like that, okay? So do the rotations preserve or change orientation? They change orientation, okay, of the figure. What about, does it change the orientation of the vertices? Okay, so let's take a look. Remember what we talked about with that. If I start at A and then go to B and then go to C, okay, so that would be a counterclockwise position. If I start at A, once we changed it, and still go counterclockwise, am I still going in the same orientation? Yes, I am. So those points are preserved. Okay, they're in the same order. They're not flip-flopped like they are when we did that reflection. Okay, when we look at our homework, we have rotations. We're going to be rotating this square 90 degrees, 270 degrees. It's very important to make sure that you're looking at the direction. Is it telling you clockwise or is it telling you counterclockwise? Okay, so please make sure that you are changing your figure accordingly. And you may need to rotate your paper to be able to see which way you're going. Again, Miss Bird and I have some strategies that we can help you with, and that kind of makes it a little bit difficult when you are trying to learn it off of the video. So again, using the marker boards with the grid on it, patty paper, or graphing paper is going to be extremely helpful. And you will have access to graphing paper on any test that we give, or the state exams as well. So anyway, good luck to you guys. Take your time. You do need to write your coordinates down in these boxes, not just writing the answer down at the bottom. Okay. All right. Thank you very much. If you have any questions, please find Miss Bird or myself, and we'll do everything we can to help you out.